Alright folks, it's Monday morning. I'm on the second floor and I'm solving the chapter 8 problems. Busy, gotta go. Okay, so what do we have here? Chapter 8, conic sections. If we've got y squared and x linear, that's gonna be a parabola. But we still can complete the square. So what can we do here? Let me rewrite it. Maybe filming in the second floor was a bad idea. We're about to find out. Sounds like a stampede coming. So what we've got here, divide by 2 and square and add to both sides. So we get 8x plus 10. So now we've got what we've got here. If we were to factor out, I'm going to talk over them. I'm stronger. The 8. We've got the form we need, which is 10 over 8. So we've got a vertex of negative 10 over 8 and positive 3. Okay, well, that's it, isn't it? Directrix there, well, let's check it out. So basically, this is negative 1.25, or rather it is 1.25. There's that vertex approximately, Queen Jane. And then we've got it opening to the right. So the directrix should be over here. And since the number in front is 8, 4p equals 8, p equals 2. So yes, the directrix should be 2 to the left of that. Okay. Okay, so we're going in reverse here. We know the parts. Let's sketch. Sketching is always your friend when you're trying to find a graph, eh? So the vertex is at 3, 2. The directrix is at x equals negative 1. Hi, Johnny. And so the vertex should be in between, eh? So it's got to be on the same line as the focus. So it should be on that line. It should be there, 1, 2. So, all right. Also, we know it's going to open to the right also because the directrix is to the left of the focus. This is the only way the parabola could open, to have the focus inside and the directrix outside. So we know it's going to be y minus 2 squared equals something times x minus 1. And what is that something? That something is the distance between, well, it's related to the distance between the focus and the vertex, which is 2. So 4p equals 8, just like the previous one. Yes, sir. Okay, what are the vertices? Probably ought to sketch again, eh? So, what are we sketching here? We're sketching a center of 2, negative 1. Okay, then we're saying in an ellipse, the a value is defined based on the bigger denominator. The bigger denominator is defined as a squared. So therefore, a is 5. But it also tells us if the bigger denominator is under y, it tells us it's vertical. So the a is 5. A squared is under y, tells us we're going to go 5 up to our vertices. 1, 2, 3, 4, 5. There's a vertex at 2, 4. Looks like it's going to be that, but let's just go to the other one. 5 down, 1, 2, 3, 4, 5. That's 2, negative 6. We could, of course, find more information about the ellipse, but let's leave it at that. Something like this. Okay. ellipse has foci here and here. What is its equation? Wow, can you guess what would be a good idea? Probably sketching. So the x value is 0. So this is going to have a vertical focal axis. Okay. Basically what we have here, we could rewrite it like this. The center must be 0, 0, because these 2 points, 0, 4, and 0, -4, the midpoint of the vertices or the midpoint of the foci also has to be the center because of the symmetry. So what's the midpoint of this is 0, 0. Okay, well all the equations here have a center of 0, 0. So what else can we surmise? We can surmise from the distance from the center to the foci is c. Therefore c equals 4. And likewise, the distance from the center to the vertices is a. So a equals 6. And then lastly, some other important detail of ellipses that we haven't yet spoken about is that when we have a squared, b squared, and c squared, the a squared is the biggest value. So, in other words, we need to add up the other two to get to the a squared. This is the equation of the relationship between a, b, and c for an ellipse. So what do we have here? We've got 36 equals the unknown b squared plus 16. Because by the way, if we just take a moment to stop here, if a is 6, we need a 36 somewhere. That can't be it. And if it's a tall ellipse, what? Sorry, the vertex is down here. If it's a tall ellipse, as this one is, the a squared has to be under y, not x. It's one of these two. But the denominator of the other variable has to be b squared. So here it goes. B squared is 20. So here we go. B squared is 20. We've got some interlopers. Just gonna keep going here. Okay, so, ooh, I was using the wrong pencil, my bad. So a brief aside here about, remember the point of conic sections is they come from the cones. Look at that sketch. I think I'd be better at it by now, but I'm not. Which conic section can be obtained by taking a double napped cone? There we go, right? These top nap, bottom nap, double napped. Probably should have a hyphen there. And slicing it perpendicular to its bases. So here's a base, perpendicular to the bases. Right? If that's the diameter of the base, we want to go perpendicular. But this question just gives it away. What's the only conic section that has two separate branches? The hyperbola. And if you take that cut perpendicular, you get the two branches. By the way, it doesn't have to be perpendicular to create a hyperbola, right? You could tilt it a bit and still be a hyperbola. Here's Frankie. Okay, here we go. The vertices of this guy. So what is this guy? This is a hyperbola. By the way, I usually like to write it like this. For both hyperbola and ellipse, I like to put the x first. And then how you know it's going to be a hyperbola is just if you put a negative either here or there. So these two things are the same. And the fact that the x is negative, that's telling you it's going to be a hyperbola with a vertical focal axis. In other words, it's going to open up and down. Well, let's start with the center, shall we? As with most of these conic sections, the center is +1, -3. Leslie? Oh, hello. And And so we know it's vertical because of the negative x. And we know in a hyperbola, the a squared is simply defined as the denominator that is under the positive term. So it does so happen here that a squared is bigger than b squared here, but that doesn't have to be the case. It's the a squared is 16 because it's underneath the positive term. And that's going to tell us, just like in an ellipse, the distance from the center to the vertices. So if the center is 1, -3, the vertices will be 4 up and 4 down from that. 1, 2, 3, 4. 1, 1. And 4 down. 1, 2, 3, 4. 1, -7. There it is. Morning.
Boys, it's 8 o'clock, so we're late now.
Mr. Tom there, for those of you who know him. Okay. Asymptotes. Guys, there's formulas for asymptotes. I'm never one to recommend memorizing formulas. Too easy to mess a detail up. Here's a detail that's hard to mess up. To find the asymptotes, replace 1 with 0. Instead of memorizing a formula, memorize that trick and use your algebra skills. Okay. So the idea is replace, for an asymptote of hyperbola, replace 1 with 0, solve for y. So if we just move this guy over, or just flip it. Y plus 1 squared over 4 equal. So if we subtract this over, we get negative, right? If we just want to go step by step, subtract this over, it's a negative equals a negative, and then just times both by -1. You get what you want. Multiply both sides by 4. Sixth graders. X minus 2 squared. Okay, square root both sides. So when we square root both sides, we have to add the plus or minus. That's where we get 2 asymptotes from. So we get y plus 1 equals positive square root of 4 over square root of 25 times x minus 2. Right? Square root, square rooting everything inside. And we also would have the opposite of that. So by the way, do notice that you might think, oh, asymptotes, they're perpendicular. Remember, they're not necessarily perpendicular. In fact, they aren't here, right? Because this is going to be positive 4 over 25, negative 4 over 25. Those aren't opposite reciprocals, just a little note there. But there's our answer. Wait, what? Oh, so this would be the point-slope form. It looks like we want the slope-intercept form for this particular answer. Y plus 1 equals -2 over 5 times x minus 2. And then we can subtract the 1. What does that sound? Okay. Which conic section is represented by this bad boy? You know, there's probably a trick to do this, to just look at it and compare some coefficients to see what it is. But let's just practice completing the square. Okay. Do you think I should use a microphone in my class? That seems like a good idea. Okay, 4x squared minus 16x. So we're grouping the x's together. We're grouping the y's together. And I can already pretty much tell this is probably going to be an hyperbola. Move the -101. It's probably going to be a hyperbola because we've got both x and y squared, so it's not a parab. And we've got a positive and a negative. Got a negative, right? It's probably a hyperbola. But let's go through. Anyways, factor out. So we've got just x squared. Factor out, so we've just got y squared. Be careful with your negative. If you're taking out a -9, this becomes a -6. And we're going to complete the square. So it becomes x minus 2 squared, which becomes plus 2. So we add 2, but it's not just adding 2, it's adding 4 times 2. Because when we add 2 here, it's actually inside the parens. There you go. And here we get y minus 3 squared, cheap, cheap, plus 9. 3 squared is 9, but we're really adding 9 times -9. So what do we have here? We've got a hyperbola. 101 plus 8 minus 81. I think I'm going to leave it at that because there's another one down here. We know it's a hyperbola because it's got both x and y squared and it's got a minus in the middle. Okay. This one, however, again, you can probably tell this is going to be an ellipse, both x and y squared, both positive. But we need to find some characteristics, so let's actually do the work. Group the x's together. Group the y's together. And we already kindly have the constant 6, 7 on the right-hand side by itself. Okay, so we're going to factor out. We're going to factor out. Those kids sound like they're having fun in the Chinese class. Okay. Now again, completing the square, being careful that when we do so, when we add in that extra thing in order to complete the square, we're balancing it out by adding the entire amount, including the coefficient outside the parentheses. Y minus 4 squared, so that means we're going to add 16 times 8. So we can do a little bit of simplification here. 6, 7 plus 5 plus 80 plus 48 is 128, I believe. Alright, keep on trucking, I guess. You know what? No, this is going to be nicer if we just add this together. Because, yeah. So it's going to be 72 plus this is 200. Okay. So remember, the last thing we need to do is to get it to look like this, equal to 1. So divide both sides by 200. Then what we get is equals 1 on the right-hand side. And here we get 5 over 200. 5 over 200. If we divide both the top and bottom by 5. 5 divided by 5 is 1. 200 divided by 5 is 40. You can basically always do this. It's basically always going to be the denominator divided by the numerator is going to be your new denominator. Why? Because you need to divide both the top and the bottom by the numerator in order to get it to 1. We don't want any coefficient in the top. So you're dividing both the top and the bottom by the numerator. So basically you're doing 200 divided by 5 is 40. 200 divided by 8, well, whatever. Be careful. I'm gonna do it. Why not? Do some work on the side. You got time. It's 25. It sounds like they're being locked in a room as it's on fire. They're screaming for help. Okay. Now some vocabulary. Semi-major axis is A. Semi-major axis is the distance from center to vertex. So we need A. We know A squared is the bigger denominator in an ellipse. So A is rad 40. So A is rad 4 times 10. So A is 2 rad 10. Okay, nice easy one. Eccentricity of the ellipse. eccentricity for any conic section is defined as C over A. That's why in an ellipse we should be getting something less than 1 because A is the biggest of A, B, and C in an ellipse. But okay, let's get what is it. So again, A squared is the biggest denominator. A squared is 36. B squared is the smaller denominator. B squared is 16. And we could find A and B, but oh wait, we will want to find A and B. A is 6, B is 4. But we can use these two directly, again, using what's called the Pythagorean relation for ellipses. Because A squared is the biggest, how is it related to these? You have to add those up to get the bigger A squared. So 36 equals 16 plus C squared. Therefore, C squared is 20. Therefore, C is rad 20. Therefore, ipso facto, put these back in here. E is rad 20 over 6. By the way, that's what cool mathematicians call square root. They call it rad 20. It's single syllable. Gotta save time, monosyllabic. Uh-oh, where's our answer? Oh, of course, we can simplify the radical. And in doing so, we see it's 2 rad 5 over 6, which simplifies to rad 5 over 3. And that, in fact, is an ellipse because, you know, it's less than 1 eccentricity. Okay, we're cruising here. Which of the following is a focus of this? Oh, we know focus is based on C. The foci are C units from the center. So we need the center and we need C. Okay, what's the center? That's easy. It's 2, 0. What's the C? Well, A squared is 9. B squared is 5. A squared equals B squared plus C squared. C squared equals 4. C equals 2. So I could go from there, but I'm gonna be careful. I'm gonna sketch it. Might as well sketch. Center's here. Because you do want to be careful, right? C is 2, but are we going 2 up or are we going 2 over? What are we doing? Well, because A squared is under X, it's wide. Wide is an informal way of saying we've gonna have a horizontal focal axis. So the foci will be right and left of the center. So the foci will be 4, 0, and 0, 0. Okay, what is one of the foci of the hyperbola? Okay, so let's just familiarize ourselves with the formula for hyperbola. Equation of hyperbola. So here we've got a hyperbola with a vertical focal axis because it's opening up and down. But let's start with the center. So the center is 1, 0. That's telling us we can always put x first. So we could do it like this. And y minus 0 squared is y squared. Now, because it's a vertical focal axis, it's going to be the x that is negative. And I'll give you a hint to just check that out if you're ever unsure and you have time to check in a moment. But let's fill out some of the other information. So we know the center from the graph, we know the vertex from the graph. The vertex, or one of the vertices rather, is 1, 3. That implies that the distance from the center of the vertex is A is 3, and that's defined as A. So in other words, A squared equals 9. And again, in a hyperbola, where does A squared go? It goes under the positive term. There you go. Now how do we do the rest? Well, to do the rest, we need to use the asymptotes. I mean, theoretically, I guess we could plug in a point. We could plug in 1, 3. No, that wouldn't work. We need to use the asymptotes. If we plug in 1, 3, it would just give 0 plus 1 equals 1. Okay, so what are we doing here? Let's look at our asymptotes. Remember, the asymptotes are based on this rectangle, or they can be based on this rectangle. And because the asymptotes go through this nice lattice point here, we know the rectangle is cornered here, here, here. The asymptotes have to go through the corners of that box. And that box has to be 3 up. We already got that. And then what are we going over in either direction? 1, 2, 3, 4. So that's telling us that b equals 4. B squared must be 16. And in an hyperbola, this relation is different than an ellipse, because in a hyperbola, c squared is the biggest. And the way I remember c squared is the biggest is because the foci are beyond the vertices. C has to be bigger than A. There it is. So 9 plus 16 equals c squared. Therefore, c squared is 25. Therefore, oh, and by the way, b squared is 4 means this is 16. So the foci are 5 away from the center. 1 comma 5 and 1 comma negative 5. We could already eliminate these. We know it has to be beyond the vertex. Yeah. Okay, let's go on. What could be the directrix of the parabola? Okay, so again, we got back to a parabola because only one of the variables is squared. Also, we know a few other things about this parabola. We know the vertex is at 3, negative 2. So remember, a parabola does have some things different than a hyperbola and an ellipse, because this part of the equation is giving us a point on the parabola as opposed to the center. Now, how do we do this? Well, the other piece of information we know is that because x is squared, it's going to be what we could call a vertical focal axis. Now, that doesn't narrow it down totally, because it could be opening up or down. And it doesn't say anything about whether k is positive or negative, so we don't know if it's up or down. So we're probably going to have to do some process elimination. So the idea here is that whether or not it's up or down, we do know something about the directrix. The directrix must be horizontal. But if it's opening down, the directrix would look like this. If it's opening up, the directrix will look like this. It has to be horizontal. And horizontal lines are y equals something. We're not going to have a vertical directrix if it's a parabola opening up or down. Okay, so process of elimination might help us here. Now, how can we figure out which one it is without other information? Well, we know one more thing. If we graph both of these, y equals 3 would look like this, of course. Y equals 3. Y equals negative 2 would look like this. Now, which of those can that be? If the vertex itself has a y value of negative 2, you never have a directrix through the vertex. This is the only possibility. You have to do process of elimination there, I believe. Okay, what is the equation of the ellipse? Well, again, start with the center. So we know we need x minus 2 squared over something plus y minus 1 squared over something equals 1. C, B, or C. Now let's check. So from the center to the edge, we got 1, 2, 3, 4. Now, is that a vertex? Remember, vertex has to be the edge, so to speak, that is a further distance from the center. So that's 4, as opposed to 1, 2, 3, 4, 5. So this has to be the vertex. And that tells us that this is a vertical focal axis. Right, the foci will also be on this line somewhere here, somewhere here. But the most important thing is that a is 5, and therefore a squared is 25. And since it's a vertical focal axis, the bigger denominator, a squared, has to go under y. And there you go. And so b is 16 instead. Okay, almost done. Let's finish this off strong. Let's do one more sketch for old time's sake. Okay, so we've got the center of the hyperbola is 2, 0. This will be nice and easy. Here we've got remember, I'll start with this. Since the y is negative, it's going to be a horizontal focal axis. How can you remember that? I guess how you can remember that it's a horizontal focal axis, right? It's going to look like this. It's like you're never going to have a point with the same x value as this. You're never going to have a point with an x value of 2, because if you plug in 2 here, you get 0 minus something equals 1. Or 0 minus something squared equals 1. Negative y squared can never equal 16. Because this will always be positive, so this whole thing will always be negative, never equals 16. So you could just remember, right, if x is positive in a hyperbola, it's horizontal. But you can always check that by saying, okay, horizontal means it's never going to have a point on this line. It's never going to have a point with an x value. That makes sense. But it could have a point with a y value of 0, right? The vertices, in fact, because you can plug in 0 here and get the vertices. In fact, that's a cool thing we could do there. We could find the vertices by finding a, or we could just do this. The vertices have to be on this horizontal axis. So they have to have a y value that's the same as the center. So if we plug in y equals 0 to this equation, we're going to get the x values. So we get x minus 2 squared. I've never done it like this, but this is actually so true. 0 squared over 16 equals 1. So you get x minus 2 squared over 9 equals 1. So x minus 2 squared equals 9. Square root both sides. X minus 2 equals plus minus square root of 9, which is 3. So x equals 2 plus or minus 3. X equals 2 plus 3 is 5. Or x equals 2 minus 3 is negative 1. So we get, that's our answers. We get 5, 0, or negative 1, 0. And we can verify that by doing it the old-fashioned way, by saying a squared is defined as the positive denominator, so a squared is 9. Therefore, a is 3, and the vertices have to be 3 away from the center. 1, 2, 3, 5, 0 is one of the vertices. Check. And 3 in the other direction. 1, 2, 3, negative 1, 0. Check. So, 2 ways to do that. And then, last but not least, the high asymptotes. Let's do the old trick. Replace the 1 with a 0 and get the following. The asymptotes will fit this equation. So let's solve them for y by getting y squared over 16 equals x minus 2 squared over 9. Solve for y by multiplying both sides by 16. And square root both sides, we get y equals plus minus square root of 16 over 9 times x minus 2. Sneak it over here. it says give one of them. Sure, let's just give one of them. Square root of 16 over 9 is 4/3 times x minus 2. That's one of them. And that is a line through the point 2, 0 with a slope of 4/3. 1, 2, 3, 4. Now, since I didn't draw this to scale, it's not going to look totally right, but it's going to look something like that. Yeah. There's your answer. All right, there's conic sections. You guys got to crush conic sections. That's your chapter. That's your topic that you guys are masters at. All right, go blue.